Buongiorno a tutti e benvenuti in questa nuova sessione. Direi di attendere giusto un minutino, giusto per far scoccare le 16 e far sì che anche chi proviene dalle altre sessioni riesca a raggiungerci e dopodiché inizieremo con questa nuova sessione. Ok. Nel frattempo che attendiamo, spero che queste sessioni, ormai siamo arrivati verso la conclusione di queste sessioni, spero che vi siano piaciute e che avete trovato interessanti le varie soluzioni che vi abbiamo proposto. Vi ricordo che se avete domande, dubbi o curiosità rimane sempre aperta la Q&A, perciò vi chiedo di postare lì le vostre domande che il quale troveranno risposta e ovviamente poi tutto il materiale visto in questa giornata vi verrà condiviso. A questo punto direi che possiamo iniziare. E questa sarà la sessione di Safe-t sarà in inglese, è uno dei nuovi vendor che abbiamo scelto in distribuzione e per questo motivo abbiamo con noi il VP di Safe-t. Perciò, oltretutto, visto che sarà non in lingua italiana, se ci fossero dubbi o qualcosa da chiarire, scrivetecelo pure che cercheremo di dare il massimo della risposta. Thank you, Hitan, for joining us. So you can start to explain us the solution that you have with Safe-t, and everything is for you. Okay.
Okay. Thank you, Christina. Thank you very much.
You're welcome.
Hi, everyone. My name is Eitan Bremler. I'm VP of Corporate Development here at Safe-t. And today we'll talk about how we simplify and accelerate customers' journey to zero trust. A bit about Safe-t, Israeli company founded back in 2013, public today, traded both in Tel Aviv and in New York Stock Exchange, headquartered in Israel, where I am located, but global in the sense of our sales and offices. We have offices in the US and Germany, UK, Spain, India, Asia Pac, and you see here in Italy as well, representatives. Global, we're selling, we're quite a lot of customers for our access technology. You can see us in all of the leading analysts, Gartner, Forrester. I'll show you a couple of examples. And of course, channel oriented. We go directly through, we go mainly through channels, could be MSPs, could be resellers, distributors. We'll talk about this at the end. As you can see here, we're a regular visitor to the Gartner reports. Since 2018, when the whole software-defined perimeter, SDP or ZTNA, Zero Trust Network Access space, has been covered, Safe-t has been a reference and representative vendor. So you can see us in our reports, also in Forrester, in their Zero Trust Access reports. You can see here that in terms of customers, we're also global and also widely ranged in terms of verticals. Could be financials, large corporations, government, healthcare, cloud. We know to sell to all of them. Could be financial banks in Europe or in Asia or in Africa or in Israel. Technology companies and manufacturing like Signify, Tuborg and Strauss in the food industry. Governments like in Indiana State of Government, Israeli Ministry of Energy, Israeli Police, health organizations and health and education organizations, as well as leading vendors like Accenture and Fujitsu, who are a customer and also a partner of ours. So what do we offer and how do we play? So let's start about kind of the market, just to set the space. So if you look today at our world of enterprises, we have two dimensions we need to look at. One is where our data is located, and data today is located on-premise and off-premise. Could be in the cloud, could be on-prem, could be AWS, could be Azure. The more problematic thing is who is accessing our data. And today, as you can see here, there's a wide range of types of users accessing our data. Could be human users, like work from home users, supply chain, contractors, remote workers, third-party vendors, employees in the office, but can also be connected devices. Now, these users are very different in their profile. Some of them are internal to our company, like our corporate employees, our workers, our work from home. Some of them are external to our company, like supply chain, contractors, third-party vendors. Some of them might be using managed devices, like our remote workers and our corporate employees. Some of them using unmanaged devices, like work from home, connecting from their desktops or externals. And while all of these users are either not our employees or our employees, trusted, untrusted, managed, unmanaged, today, most likely they use a VPN. So all of these users use the exact same technology, VPN, tunnel-based VPN or portal-based VPN. Many use tunnel-based still. And while VPNs have been with us for the last 20 or so years, they are a tried and true technology. They have their issues. They don't fit all of the use cases. They're really designed for our trusted people. But as we see, we also have untrusted people, like our employees or people coming off unmanaged devices. These are less trusted. VPNs are less fitting to them. Why? One, because VPNs are client-based. I need to install a client on my machine. It's one thing installing a client on a managed device. It's something else installing it on an unmanaged device. Two, VPNs connect me into the network. Even though I might only need specific access to a specific application, I get, in case of tunnel-based VPN, flat network access, which is really bad if I'm talking about non-employees. A very wide attack range, lateral movement. Three, VPNs hold everything. They do the access, to authentication, to authorization, all in the same machine. Number four, VPNs are vulnerable, right? And every day we're seeing more and more VPNs getting hacked. So while this technology might really fit the people I trust, the employees working from home on my company laptop, where I don't have a problem of them connecting into the network and getting wide access and everything, it's less fitting for people with unmanaged devices or outside of my organization. This is where the concept of zero trust and specifically zero trust access comes into play. If I want to do zero trust access, which means trust nothing, always verify, I need to do three things, which today a VPN doesn't really do. I need to do continuous authentication, which means not only authenticating people at the beginning of the session, but also during the session, right? It's not enough to know who is connecting. I want to know and maybe authenticate them when they are connecting to a specific application, which is potentially higher priority or more sensitive. Two, I need to do least access privilege, right? Not give network access, but give specific application access. There's no reason for a user today to get network access. If all I need is connect to my SAP or my file share or some web application, I only need to connect to that. There's no real reason to be granted network access. And last but not least, I need to strictly monitor and enforce the user throughout the session. If we deploy these concepts, then we're moving to zero trust. Then we can start granting access in a much more secure and less risky way. Now, there's a lot of zero trust network access players in the market with different vendors. Safe-t is one of the first ones. We've been doing zero trust network access for the last 3 years already. Our product is called Zone Zero. It's a perimeter access orchestration solution. The idea behind Zone Zero, which is a fully software product, is to unify all access use cases. Again, we have work from home people. We have corporate employees coming into the network, logging their laptop into the docking station. We have people coming in over VPN. We have external users. All of these use cases are addressed today by Zone Zero in the same solution. So by deploying Zone Zero in your network, you can now unify all access. We do this by integrating 4 main technologies. One is Safe-t reverse access patent, which is a logical segmentation technology to reduce the attack surface, closing firewalls where firewalls can be closed. Our software-defined perimeter technology for non-VPN users, a VPN replacement in a sense. Integration into corporate VPNs to support VPN users with zero trust. And integration to MFA to support internal users using zero trust. The idea is to sit between the users and the resources. By sitting between all types of users, humans or non-humans, and the data, we can now add zero trust to all access scenarios. So how do we do this? what he actually sells. Like I said, we're selling a software product. Zone 0 essentially comprised of 3 virtual machines. Depending on the use case, it could be 3 or 2, or we'll talk about this. The main component of Zone 0 is the access controller. It is the main virtual machine, the main component. It connects to the corporate resources, and only it connects to the resources. It connects to the organization IDP, be it on-prem or cloud, and it connects to the authentication gateways. Could be safety authentication gateway, could be the VPN, and the safety access gateway. Why do we have 2 gateways? Because we want to split authentication from access. Before you can access a service, you need to go through authentication. So the user has to go through authentication first, and only then are they granted access. If it's a safety non-VPN user, they will authenticate using safety authentication gateway with a web portal. If they are a VPN user, they'll connect over the VPN gateway and then connect to the access gateway. So this is the technology. The basis for this technology is what we call the reverse access patent and the reverse access technology, which is essentially depicted by these 2 arrows here. The access controller manages the gateways. It configures them and it pulls data from the gateways. There's no push. The gateways, neither the access gateway or authentication gateway, never talk to the internal network. They cannot push traffic into the internal network. The access controller is the one going out to the gateways, taking data, pulling it in. So let's zoom in into the patent and see how it works. So let's zoom in for the access controller and access gateway. As you can see here, the access controller goes out to the gateway. So if I have a firewall here, this dotted line, it is configured from the inside out. There's no inbound rule required. Now, our solution is TCP based, so it works for any TCP application. If I'm a user wanting to connect to a business application, SAP, FileShare, RDP, I open the relevant client application, point it to the access gateway, and send my TCP traffic, essentially connecting if I'm talking application. The TCP traffic hits the access gateway on a designated port. Access controller goes out, takes this traffic, pulling it in. So it's a pull, not a push. It's not the access gateway is not pushing in. Controller goes out, takes the traffic, sending it to the business application, and the response is sent back out. This way, the user is talking to the application without needing to open up the firewall or deploy a VPN. This solution can also be deployed cloud to ground. Think about a cloud scenario, AWS, Azure, where you put your front end in the cloud, and that has to talk to a SQL database, for example. Today, you would need a VPN. You'd put a VPN in your DMZ and go through it. With our solution, all you need is the access gateway running in the cloud, the access controller running on-prem, client application sends traffic to the access gateway, controller goes to the access gateway, takes the traffic, sending it to the relevant database. This way, an application can talk to an internal component without exposing the firewall. So this is the basis. Now let's see how we deploy this within Zone 0, and we'll start with our SDP scenario, which is our non-VPN scenario. So what do we offer? Okay, we took the 3 virtual machines and we broke them apart, placing the controller in the LAN, the access gateway in the DMZ, and the authentication gateway could be running either in the in AWS or in Azure or even on the DMZ. And the access controller connects to the backend applications. It connects to the gateways, configures them, and connects to them to pull traffic. It also connects to the identity provider on-prem or in the cloud. We'll in a few minutes we'll see a demo of this, but I'll explain the flow before. So if a user wants to connect to a backend application, all they need is a web browser for the authentication phase and the relevant client application for the application they want to connect to. If they're connecting to RDP, they need an RDP client, MSTSC. If they're connecting to SSH, they need an SSH client, like PuTTY. If they're connecting to SAP, they need the SAP client. If they try to go directly to the access gateway, they will be blocked. In order to connect, you first go to the authentication gateway over browser, and you authenticate. The authentication flow is managed by the controller and the authentication gateway. So the controller will go out to the authentication gateway, take the information, and send it to the relevant identity provider, or redirect the user to the identity provider. After we authenticate the user, we know the group the user belongs to. The access controller at that point will instruct the access gateway, please open the relevant ports for that user. And then a user can be able to connect. What does it mean connect? Open the relevant client application, point it to the access gateway, and send the traffic. And based on our reverse access patent, controller goes out, takes the traffic, and if it's RDP, we'll send it to the RDP server. So essentially, a user, after authentication, can connect to any backend server and service allowed to them without opening the firewall. The firewall is closed, it's only open outbound, and it's completely clientless in terms of safety. There's no safety client. So you can connect a user to specific applications without granting the user network access, only application access. This is the on-prem version. We have a cloud version or hybrid cloud version where the customer runs the controller in their premise, and safety, we run the gateways in our cloud dedicated for that customer. Same solution, the customer manages the gateway, the controller, because the controller is the brain, but the gateways run in the cloud. Another option is our MSSP offering. We have MSSP providers offering our service under their brand. So they would sell the controller and the gateways and either manage only the gateways or manage both the gateways and the controller. So that's our SDP, that's our non-VPN solution. Now let's see a demo of what this looks like. Okay, so let's start with a demo, and we will see how the SDP would appear. Christina, can we see the demo? It is working?
Yes, we can see
perfect.
your web page.
Can I see the, yeah, okay, perfect. So I'll start the demo. So what we see here in the demo, this is the web portal the user sees when they log in to the authentication gateway. As you can see at the top, we have the URL which we publish to the user, and on the right-hand side, the flow the user is going through. We'll start with the basic username and password flow. The user inputs their credentials in the authentication portal. The controller goes out to the authentication gateway, retrieves the credentials, sending them to the Active Directory, in this case, over LDAP. We get a response from the Active Directory approving the user, and we get the group the user belongs to. That defines the applications the user can connect to. As you can see, I can have GitHub, SSH, and remote desktop. Now, all I need to do is either click this shortcut, which is a Google Chrome shortcut for popping up applications, or just open my MSTSC client and point it to the relevant application. In this case, my remote desktop. Okay, pointing it to my access gateway. As you can see here, on an RDP port, traffic is sent to the access gateway, controller retrieves it, sends it to the RDP. The user is now connected to the remote desktop. Okay, but there's no network connectivity. It's only application level access. The same I can do with SSH and connect to an SSH machine without being in the network. Okay, this is SSH traffic from the user to the access gateway. Controller goes out, takes the SSH traffic, sending it to the SSH machine. If I log in, if I sign out and log in with a different user, you will see, in this case, the user is called Johnny. I connect with that user, I will get access to different applications because I belong to a different group. Okay, so different applications. Now we can do other types of flows. For example, a username and password plus MFA by Duo. So we have integrations with Duo and Thales and Okta and Ping and Telegram and WhatsApp and SMS, a wide range of IDPs and MFAs. So in this flow, after I put in my username and password, I can get a push notification to my Duo mobile phone, my Duo app. Only after approving the push message will I be connected to the services. And again, all of this is done without requiring a safety client. So it's authentication using the browser and using a client application to connect. So this works for tablets and phones and PCs and laptops, whatever you need, managed or unmanaged. So this is the safety SDP use case. Let's go back to the presentation. So this was the demo for the SDP use case for non-VPN. However, research shows that a lot of organizations use the VPN, and VPN today is a hindrance for them to switch to SDP, which the SDP story is usually VPN replacement. Understanding that if we want to help people do zero trust access, when VPN is a very strong technology in the data center, we need to work with the VPN. Not everybody would agree to replace the VPN. For that, we deploy Zone Zero VPN. It's the same product as the non-VPN, the Zone Zero SDP. We call this Zone Zero VPN. Only instead of using the web portal for authentication, the VPN acts now as the authentication gateway. So the user, instead of using the web portal for authentication, uses their standard VPN client. Could be Fortinet, Checkpoint, Cisco, F5, Palo Alto, Pulse, whatever the OpenVPN, whatever VPN the customer has. You do the authentication using the VPN does the authentication, but that does not end there. Safety reads the VPN user table, or the VPN update. Safety really depends on the VPN provider. Once we see a user has been connected, we send the user an MFA, either a safety MFA or using a third-party provider. Why do we want to send the MFA? To prevent VPN vulnerabilities, to prevent people bypassing the VPN. In some cases, the VPN is old and doesn't even support 2FA or MFA. So by adding this layer of defense, we're essentially protecting the network from VPN vulnerabilities. Once we finish this flow, only now do we open the access gateway. And now when the user wants to connect, they open the relevant client application, connecting to the internal IP address in the network, but the traffic hitting the VPN is routed to safety. This is the only change we do in the VPN, a routing change. Instead of routing into the internal network, you route to safety zone 0. And we, using the reverse access patent, send the traffic into the network. So essentially what happens now, we elevate the user to do application level access. No more is there network access for the user into the network, even if they're using tunnel-based VPN. The user is only talking to the application allowed to them. Okay, so this is a very unique breakthrough in the world of VPN. Today, when we're talking tunneling, we're talking layer 2 tunneling into the network. This is the first time we can actually break the layer 2 tunnel into the network, yet allow people to connect to their internal network resources. So from what are the benefits here? From an operational perspective, it's transparent. You put us in the network after the VPN, route traffic of the VPN to us, and that's it. Very easy, very quick to implement. No real changes on the VPN. No changes to the security policies. We upgrade the user and the VPN from layer 2 to layer 3, 4. Okay, we're now talking application level access. We isolate the VPN and prevent the vulnerabilities. You get authentication first, access later because of the zero trust concept. No open ports. Really reduced attack surface. Now, the same technology, before we go into the demo, can also be used. So we talked about non-VPN users. We talked about VPN users. Now let's talk about internal users, people coming into the office. We don't want to forget them. Now, people into the office, you say, okay, what can I do for a person in the office? They came in, they authenticated to the network, right, into the domain. The next thing you would want to do is MFA, right? If I'm connecting to the network and I'm now going to some backend application, I would like to do MFA for that. That's basically the only thing we can add in addition to logical segmentation and segmenting users from applications or micro-segmentation. However, adding MFA today to internal services is very, very complicated. If it's web, it's one thing. You could redirect over OpenID Connect or SAML. If it's non-web, if it's client-based applications, it's really complicated to add MFA. In some cases, there's no support. You need to go into customization, development. What we allow to do, oops, sorry. So put in the wrong slide. 1 second. Sorry about this, people. Okay, sorry about this. So this is the use case, right? We're talking putting Zone Zero MFA as a solution for zero trust for internal users to sit between a user and the application. It's the same product, only sitting between, instead of external users, we're talking internal users. Now, Zone Zero can work in 2 modes, in a segmented scenario where a user sits in network 1 connecting to network 2. In this case, we sit between the networks. We intercept user traffic. Once the user authenticated to the network, now any traffic of that user going to a backend service, which we define is sensitive, we can intercept and send MFA. So if I'm a user and I want to connect to, if I'm a user wanting to connect to my SSH, once I open my SSH client, that is intercepted by Zone Zero, which invokes MFA. Could be an SMS, could be a push. We also know to sit in a flat network as a gateway for applications. This is good if users and applications are in the same network. In this case, when a user sends traffic and connects to the SSH and the SSH gateway wants to authenticate, they request Zone Zero for authentication. In this way, we add MFA to any backend application, be it SSH, SAP, file shares, remote desktops, any backend application, legacy or not, mainframes, we are able to add MFA to that, which is a big leap for internal users who we always trust. But this is how insider threat starts, by trusting our internal users. By adding MFA to stuff which is sensitive, like file shares, like dedicated special folders with financial information, we can prevent data theft. So let's see what this looks like in terms of a demo. So let's switch over to our demo. Christina, can you see my demo?
Yes.
Okay, now yes.
Okay, perfect.
Maybe I have some delay.
Yes. Okay. So what we're seeing now, this will show you the Zone Zero VPN and Zone Zero MFA use case. So what we're seeing here is a desktop of a user. We have here in the middle the user VPN client. We have at the top right-hand side the Telegram for the bot for MFA and the different applications the user can connect to. Now, the user authenticated to the VPN. In a regular world, that would be enough for the user to connect to a backend service, either my web service, my remote desktop, or my file share. What Zone Zero notices, as you can see here, is that the user connected sending a push message. So we modified Telegram to act as a MFA. If I disregard this message and try to connect to any of my backend services, you can see I'm blocked because Zone Zero is blocking access. Whether it's web, remote desktop, file shares, I'm blocking access. Only if I respond to the push message, and this could be this Telegram, could be SMS, could be Duo, could be Thales, any option of MFA. Once I respond, that is validated and authenticated by Zone Zero. Only then can I connect to my backend services. And I'm only connected to these services. There's no network access. It's only application level access, although I'm on a tunnel-based VPN. In this case, Sophos VPN, which is what we have in the lab. And you can say I can connect to my file share, my remote desktop, or my web. Now let's take a follow-up use case. User is already connected, either a VPN user connected or a network user connected. I'm now trying to go to 2 services who we deemed and configured as sensitive, a network share and a remote desktop. In regular world, there's no MFA here, right? You just connect. But Zone Zero, sitting between the user and the application, notices I'm going to a sensitive service, sends me a push message to authenticate. As long as I did not approve the push message, you can see my connection is held. Once I put in my MFA, I'm approved, and I can connect to my backend service. This could be remote desktop. This could be a file share. So essentially what we get here is the ability, and going back to the presentation, is the ability to add MFA to any backend service. By deploying safety, what do you get? You get first security, zero trust access for all access use cases, internal users, external users on VPN, external users, non-VPN, no lateral movement. We're only connecting to applications, regardless of the use case. Internal, external, VPN, it's all application level access with no lateral movement. Using our reverse access patent, we really reduce the attack surface, preventing people moving around the network, prevent hacking through the firewall. It's simple. It's very fast to deploy, so it's reduced time to market. It's clientless and it's seamless for the user. You don't need to learn much to work. It's BYOD and BYOPC supported, completely unmanaged. It's cost effective because there's no client installation. It fits all market sizes, enterprises, SMBs, etc. And it's very flexible. You can support humans, IoT devices. You can run on-premise, you can run in the cloud, support new and legacy applications. Now let's see a few of our customer case studies of how they used Safety Zone Zero. The first is Signify. This is Signify out of the Netherlands, a connected lighting manufacturer. As you can see here, they run the safety solution fully in AWS. They themselves are an AWS shop, and they wanted to do zero trust access for remote developers to backend networks. And they thought how to do this without a VPN, people coming in from around the world through the cloud. They deployed our SDP as a SDP zone within AWS. Very easy, up in a few hours, everybody connecting, authentication first, access later. So this is fully cloud in a sense. We're also part of the AWS marketplace, so it's easy to consume us directly from AWS. This is a fintech company out of Germany. They kind of did a hybrid approach here where some is on-prem, some is in the cloud. They're regulated, so they had to own the solution, but they wanted to really separate authentication from access. So they put the authentication gateway in the cloud. Different types of users you can see here. There's a remote worker and partners. Remote workers connect over and authenticate over Azure AD, while partners authenticate over a database, and they're connecting to different applications. So the same solution can use authentication from different IDPs and allow connectivity to different applications. This is a university here in Israel called Ariel, who actually joined us as part of the COVID. From today to tomorrow, once people went home and there was a lockdown, they sent all of their employees home. However, these people never worked from home, so they used their work desktops. And the university had to find a way to connect a person from their home desktop to their work desktop. And you could not use a VPN because these are home desktops, by definition unmanaged. So they deployed our hybrid SDP offering. Gateways in the cloud, controller in the data center, user goes home, opens their home desktop, authenticating to the browser, connecting in to their RDP. This is a food manufacturer, same story for COVID, right? Connecting over our hybrid solution from home for admins and different management people to their work desktops. This is a national water company, highly regulated, so everything on-prem, controller and gateways. Users are remote. These are people who do water metering using their mobile phones, so they could not deploy a VPN, yet needing to connect to legacy apps in the background. They deployed our solution on-prem. Very easy, can connect from anything in any type of device. This is another fast food company, okay? Also for COVID, you can see also the hybrid. So this summarizes the presentation for this section. I'll be happy to open it up for questions.
Okay, thank you for your explanation. Just to let me check, we don't have any question right now, so we're waiting maybe a minute to wait if someone has any question or any doubt. I try to also, sorry, I switch in Italian for a minute, ok?
No problem.
Vi ringraziamo tutti quanti per aver seguito questa sessione. Se attualmente avete domande, ok, we have a license. We have a question, sorry, but is late. Which is the license model for Safe-t? Can you explain us?
Yes, so we license based on user. So it's user licenses. Annual or perpetual, really depends on the customer. In some case, it depends if it's an SMB or enterprise, do we charge on servers or not? But essentially, the basic is user licenses, registered users.
Registered user, okay. Is a subscription, so is
yes.
Okay.
Annual subscription, yes.
Okay, perfect. And there are some steps. So, for example, the customer can buy a package of 10, 12, and so on, or
yeah. So we have different levels up to 100, between 100 and 500, I think. But yeah, you can grow for sure.
Ok, perfetto. Spero che questa domanda appunto sia stata, la risposta sia stata esaustiva, e a questo punto non so se avete ulteriori domande, attualmente non ne vedo. Nel frattempo vi inviamo l'ultimo link per la prossima sessione, intanto che aspettiamo. Questo è il link. Ok, thank you. So, Ethan, I think that we explain well, because we have only one question and you explain well. So, and I want to tell you thank you so much for your explanation and for your time to spend with us. And we see you soon, and we'll send the material that you explained to all the participants.
Great.
Grazie a tutti e ci vediamo nella prossima sessione. Thank you, bye.
Bye bye.